Hello, everyone. Thanks for joining and welcome to another session of our Day One Beyond series, where we take you through various topics and activities related to building out on Oracle Cloud. Our today's session is building agentic AI apps from zero to hero on Oracle Cloud, which will cover AI agent systems in OCI, model context protocol, as well as leveraging AI models, external data sources, Oracle database, web search, RAG service, and local file systems. I'd like to introduce Anoop Oja and Joe Han as today's presenters. That being said, I'll hand over to Anoop.
Hello, everybody. I hope everyone can hear me loud and clear. Before I introduce myself, maybe Joe, why don't you start there?
Sure. I'm Joe Han, a data scientist, and I help Oracle Cloud customers ramp up their analytics and machine learning on their data in the Oracle Cloud. So I'm looking forward to co-presenting with you on today's topic about agents.
Thank you, Joe. Hello, everybody. My name is Anoop Oja. I'm a master principal cloud architect. I work for our Gen AI Center of Excellence at Oracle Engineering team. So most of my experience has been in building enterprise great applications. And lately, in the last couple of years, I've been spending my time with building Agentic AI. So we'll walk you through today. This is the agenda. At a very high level, we want to give you a good understanding what is an Agentic AI framework. So we'll spend some time there. And then we're going to build an Agentic AI app. It's called DB Operator. So just think about an agent that we are building, and we're going to demonstrate that agent throughout this webinar. But you can take the same learning and build your own agents, or any other agents that you have to build for your organization. So you can take those learnings along with this session today. And then obviously, we're going to walk you through each and every step that is required to build this Agentic AI application on Oracle Cloud. We'll give you a demo. We have recorded the demo, but we'll walk you through the whole demo, the entire DB operator, how it's going to work for us. And then we'll leave you with some good resources at the end. Mostly you'll get a source code, the DB operator. We'll share GitHub repos and things like that at the very end for us. All right. So let's get started with an overview of Agentic AI framework. So if you look at what we have seen, and this is my experience, that's what Joe and I we're going to bring here to the audience. In the last 2 years, as we started working on mostly for Agentic AI, you go back 2 years, that's where I believe we all started with ChatGPT, right? It was really good at writing emails, text generations, and that's where we call it author. So back then, we really saw how large language model took over the whole internet, and we were really able to get a foundational model. That's what we call it, right? This is a basic foundational model. Again, like ChatGPT, today we have Grok and many more foundational models out there. But then in the last 2 years, maybe in the last 1 year, I would say this foundational model found a new home and called chatbot. So you started seeing a lot of chatbot everywhere. And these are agents. These are agents that can take a question and that you can answer based on a prompt that you're asking. So you're asking questions and then you're getting an answer. So these are typical what we call agents. These agents obviously leverage the foundation model, which is the author that we saw before, right? So that was one step ahead. Today, where we stand is actions. We call them agentic AI. So with actions, they have a capability called react. That means reasoning and taking actions. And that is where we see a lot of complex workflow has been built. This is where we see agentic AI can really solve business problems for us. Real enterprise problems has been solved or is getting solved today with agentic AI, and that's the future. That's where we live today, and we'll see more and more agentic AI coming into play. And in today's webinar, we'll walk you through, right, how exactly to build an agentic AI. So we'll talk more on the action part of the whole workflow. Well, this is an anatomy of an agentic AI framework. The one on the right side, and you can read the one on the left, the features. But if you think about a large language model, so think about those are the foundational model. But this foundational model today has a lot of capabilities. We call the React capability. So it has moved from a static large language model to a model that can think. So the thought process, right? So when you ask a prompt, the model is able to think about the prompt. It's then able to take an action. So these actions are getting executed, right? And these actions are based on something called observation. So in this case, you can think about an agent like human being who can see some knowledge. In this case, the knowledge is referred to as resources. And these resources, I need to take an action. So the agents will take an action against the resources. And while taking an action, it will also apply guardrails to make sure there's ethical AI, right? So this entire middle box is what is comprising the brain of the agent. Now, if you think about a human being, right? Like today, I have to give this webinar. I cannot give this webinar without the tool called Zoom, which is really an awesome tool. So similarly, for an agent, an agentic AI application, what we're talking about, cannot do or perform a task or an action without tools. So tools are very important. So you'll hear a lot about tools today because that's, as I mentioned, without tools, you cannot build an agentic AI application. And at the same time, as you're building these, React framework, that agent that can think and take actions, you also have to give context. In this case, we are giving the agent context from memory, right? These are short-term memory and long-term memory, where the agents, as they decide to take an action, it can also go back to the previous prompt or maybe the last 10 prompts that you asked for, and then really takes an action on a more holistic way, right? So that is called context. So that's what brings in. And obviously, prompt is what makes an agent uh, achieve a goal. Because if you build an agent has a goal to achieve, and that's where you give a system prompt. Here, we're just not talking about user prompt. We're talking about a system prompt that gives an agent a role, a goal to work against. And obviously, at the end of the day, an agent will have an interface. That interface can be a UI, that can be a REST API, or can be embedded within your application, right? That's how you're embedding your agentic AI. And obviously, you also get a response. So that's an anatomy of an agentic AI. You'll see more and more as we talk through this. Please remember this slide going forward, because I'm going to refer this slide every time I speak through my process today. All right, so let's build an agentic AI app. We're not going to show you code. Again, we'll share the code through GitHub repo, but we'll walk you through the process that is needed to build an agent. So here, I want to give you a big picture. This is my DB operator. When I say my DB operator, this is a custom-built agent on Oracle Cloud. We use a lot of technology, as you can see, and I'll walk you through each of them. So the one here in the middle, this is the AI agent. So this is the brain, as I mentioned, if you remember the slide before. So this is the one that has the React capability. Now, an agent cannot do anything without the large language model, as you saw that. So we're going to provide some of these large language model capability. So within Oracle, we can provide all the frontier models, the Llama models, the Cohere, OpenAI, Grok models, and you can also bring your own. But for this DB operator, we have played around with Grok models or the Llama models. So that's what we're going to use for the rest of our demo. But you got the idea. So now that I gave this agent a model that can think, that can react. So what actions can be taken? So remember, I talk about environment, enterprise resources, right? So look at the right side. So I gave this agent a resource, an Oracle database. This database can be Oracle 19c or anything, and this database can run on the cloud. This can run on your desktop, doesn't matter, or you can run on-prem. The next one I have here is DB tools, because this agent, as it operates against the DB tool, I also need to understand, is my database up and running? What state is it on? Is it stop status, start status, things like that, so I can really operate on my infrastructure. So that's mostly AI ops, and I'll talk a little bit more what it does later on. And then we also introduce a knowledge base, because as my agent has to operate against my Oracle database, in this case, I also want to make sure this agent really understand what it takes to work against an Oracle database, because these large language models are really great. They're trained on certain data, but not all enterprise data is getting trained on, right? That's your own enterprise data. So this can be an example of your own enterprise data assets that you have. But for this DB operator, we train a RAG model, a RAG search engine, where we put in some of the documentation that is trained on Oracle 23.ai database. And at the last one, in this case, is internet search, because we want to give more wings to this agent that is just not enterprise data. I want that agent, which is the DB operator, to be able to go to the internet, do search against a particular URL. I'm just doing web scraping, right? So those kind of technology we applied here. And then at the top, you'll see a Python tool. This is a custom written tool, because as we write prompt against my agent, you will see the large language model writing Python code on the fly. And then this Python code has to be executed at a particular instance. So I'm giving them a scratchpad where that Python code generated by the large language model by my agent will get executed. And obviously, to do any of this work, you will need a local access to a local file system. So that's what we are building, right? So maybe I get the data from the internet, I store it locally, and that's where I'm going to save it and store it. So this is the idea. And then obviously there's a front end. So keep this big picture in mind, because this is where we're going to, again, build our entire workflow, which I'm going to walk you through how to build this agent from zero to hero. That's the whole topic today. Well, let's dive in.
Hey, Anoop, this is Joe. Can I just add some color commentary here?
Go
I
ahead.
think what we want to communicate to this audience is that you've built this agent to manage your database. The database is a complex tool. It requires a great deal of expertise. And those experts are database admin gurus, so they have a lot of knowledge stored in our Oracle documentation about managing that database. And your goal here, I think, is to show off how an agent that is designed to manage a complex tool allows you to interact with that tool like you're the database guru. Technically you're the cloud architect, so and we work for Oracle, so you know something about the Oracle database. But I think neither of us claim to be database admin gurus. But by designing this agent to manage all that guru knowledge, which is partly stored in your RAG knowledge base, that's where you loaded your database manuals. You also have a web search tool there, so it can crawl the web. And when you, the user, ask questions of this agent, it will find the relevant, that tool will find the relevant facts from either online sources or your RAG agent source, as well as your Oracle database source. So it's a tool that allows you, a somewhat expert user, to scale out and use our database in a very efficient way. So, and I think later on the phrase you'll say later is it allows you to scale out in a 30 times sense. What used to take you hours to manage, this complex tool now takes you seconds or minutes. So this is just for the audience to know where this is going with this agent. And it's a very generic tool. This can be reapplied for other complex tools or systems.
Absolutely. So this is just an architecture, and you can take this design thinking and apply and build your own. All right, let's go to the step involved in building Agentic AI app. I want to make sure we all understand, the audience here. There's a process to building any applications. Like we have seen SDLC process before, but to build an agent, this is not mine. This is mostly an industry best practices, a 7-step process. And I have built many agents, and I have followed this process, frankly. And I have also sometimes not followed this process. And I've realized if I follow this process, my agents ended up in production. And if I do not follow this process, I realize they have been mostly experimental, right? So this is a great way to think about, if you're building an agent, you want to follow this step 1, 2, 3, 4 up to 7, and that goes in the sequence. But think about this as all Lego pieces, right? So we can have all these different Lego pieces, but then I need to build this Lego, the final output, which is the agent called DB operator. So I need to combine all of them. That's what we're going to show you. So we'll walk you through each and every step, step 1 to step 7, and in between we'll show the demo for you guys. Well, let's deep dive into each and every step. I think the step 1 is where you define the agent without giving a goal. That's why we call it a goal-oriented agent. In this case, in the example that you will see, DB operator, the name itself says that this agent somehow operates against a database. The personas we talk about will be around database administrator, database developers, or data analysts, right? So that's the entire context and the role and the goal of the agent. And you define those at the very beginning. So I give a context, and we'll talk about more what the context is in my next slide. I give the role, which is nothing but you are a database operator. So make sure there's no hallucinations, right? So that's our goal. That's where we'll add more context. And we give some objective format, how you expect the agent to talk to you. We put some constraints because this is going to be mostly around data. So we're going to use a lot of natural language to SQL. So those are some constraints, and then the tone and the style. So this is very easy to write. And we're going to define that. You'll get the source code, but just for the context here, this is where my code resides. This is what you're going to get. But if you look at this DB operator, very easy to write. This is where I have a prompt. That's a system prompt. If you remember the first architecture diagram, the anatomy, we have to write the prompt, the system prompt. We define the DB operator. We give some context. I'll talk a little bit more what all the contexts are all about. We give a role, enter knowledge base queries using RAG, execute SQL queries safely, and returns, the results. Use the sandbox Python code for computation that I talk about, and use some web search to go and retrieve data from the internet, right? And then you give an objective of each and every of these this agent, what it has to do, and the format, the style, the tone, whatnot, the constraints, right? These are some of the constraints. So these are again best practices that you want to apply when building an agent. And that's step number one. Remember, we are not yet
Hey,
at,
Anoop, I
yes.
think we want to highlight that
Mhm.
although this is reams of code stored in GitHub, the way you tailored all this open source code is by just defining what the service does, what your SQL agent or your SQL tool is going to do, and your RAG tool is going to do, and it's all just it's just a few sentences in very human readable text. It's you yourself who are applying this agent to other use cases, other complex systems. You don't have to write code. You just merely have to write descriptions of what the tool will do, what the goal of the agent is. So it's almost no code at all. It's very low code. It's just adapting those few paragraphs of text you see there for different use cases and different tools.
Correct. And as you build this goal-oriented agent context, right? So we are really moving from prompt engineering to context engineering. I talk about that three phase. The one in the middle, the agents that we talk about, it is really good at answering. You put a prompt, ask a question, and then you get an answer. But as we move to agentic AI, we're gonna bring more context to the whole agents that we're building. In this case, let's talk about DB operator, right? So I understand that this DB operator, if I just ask, say, hey, convert my natural language to SQL query, most likely it will do it because we have a good large language model that really understand, analytic SQL. But then I have other things to do, right? I want to also make sure we give memory. So that's a memory context to be applied. I talk about I need to give access to my local file system because I have a lot of data in my local laptop. I need to extract the data. I need to download data. So that's where I need to give access to local file system. So that's where we bring more context. And just not that, we also want to bring more context from the unstructured world. So the example that I took, hey, if I build a agent, I want to also understand before I write a single query against the Oracle database, I want to make sure I let the agent read Oracle documentation so that it trains the agent by itself. We're not training the large language model here, right? We're not fine-tuning the model. It's as is. But by bringing in unstructured data, in this case, I trained a vector database, a RAG service with all Oracle documentation for 23.ai database. So now, if I ask a question to my agent and ask them to operate against an Oracle 23.ai database, most likely the agent will go first and find what are the best practices from that knowledge base. So that's super important. And you can think about this applied to your own enterprise, right? You can go to your own enterprise data and then get more, train the agent. So that's where the unstructured data context comes in. And then obviously you have the structured data, and I talk about the web search also. So what, in a nutshell, what we are trying to do here is make this agent a super user, a super agent. And frankly, I'm not a DBA. I have not spent my time doing database administration work. I did everything else, by the way. But by building this DB operator and we'll show the demo, my performance has gone from 0 to 30x. If not 0, maybe 5 to 30x, right? And how could I do that? Because I am building an agent that has context. It really understands a lot of things, just not NL to SQL. That's the whole idea here. So that's what you define at the very beginning. You really have to understand the role of your agent, what you're going to build, and try to think about what is required to achieve my goal. So the next step is step 2. And I've seen this, beginning of building an agent, people start talking about what's a large language model, what not. But you only pick a large language model that is based on your step 1, the goal, right? Remember, my goal in a very nutshell is to build a DB operator that has all the context, that really understand natural language questions, things like that. So I need to choose the right model. So here we chose, as I mentioned, the Grok model that really understand very well NL to SQL. We can also operate against the meta models, the Meta Llama 3 models or the 4 models. And within Oracle, we provide you a managed service. So again, within the managed services, I can bring any models or pick a model that really helps you to build this agent. We also give you options to bring your own model. That's the Hugging Face, or you can bring it from your own fine-tuned model from within your enterprise. We have something called Oracle Data Science Aqua, Oracle Data Science Quick Action. Aqua is the short name for that. And behind the scene, obviously, we have a lot of GPUs within Oracle Cloud Infrastructure. We can support that data science platform called Aqua and run a model of choice. And remember, my model does not need anything else from the Hugging Face because we already know Grok, which is available within OCI, does the work. But if you are building a agent, your goal is to do something else, and that goal, for that, you need to find the right large language model. Yes, why not? Go ahead, do the research, bring it on, and we provide you the infrastructure or managed services to build the agent. So that's where step 2 comes in, which is, I only get step 2 once I know the role. Let's go into step 3. I talked about tools, and I said that's something I'm going to spend more time. So this agent, I give a lot of tools because context. Remember the context that I talked about? So tools are a way to get to my resources. Remember when I said at the beginning, you cannot take an action. Like I'm giving this webinar, I could have not done this webinar without Zoom. Same thing. For my agent to do the work that I want to do, I need to give tools, right? So I gave a local file system tool. I give the Python Scratchpad. I give a web search Tavily. I give a data operation for SQL CL that we're going to work against. AI Ops, DB tools. This is again, where we're going to know the status of my database system, status of Oracle Cloud Infrastructure, things like that. And then another custom tool, the RAC services, where we're going to go and do knowledge sharing, right? So this is the tools that I brought in. Now, tool building is art, right? So you can write a lot of own code in Python, Java, however you want to build it. It's like, building microservices. Now, with the next generation of, agentic AI, what we have seen is MCP. It's a protocol. This protocol exactly came like a year back, November of 2020, maybe around that time. So this is the most highly adopted protocol. It's called Model Context Protocol. What it does, or think about this MCP as a USB-C port. So I have my before MCP and with MCP, right? The picture tells a story here. Without MCP, I will be, getting my agent connected to my database, to my API in all different ways. So people can do their own, way of connecting. Somebody will embed the code. You can write the code to do a JDBC connection to a database or to an API. You use a REST or a WSDL or whatever, however you want to connect. But with MCP, it brought in a protocol that streamlined the whole interaction. Because again, tools were so important in this whole agentic AI, there has to be a protocol. So what MCP does, it gives you a path to your resources. So think about an MCP as a USB-C port, as an adapter that can connect to your resources. It acts as a tool. It takes a prompt. So the agent, and we'll show you more in the demo, right? where the agents, you can give a prompt to the agent, and then that prompt gets converted by the large language model, and that output from that large language model goes to the MCP protocol to the resources. And then at the very end is the transport protocol. I'm going to talk a little bit more on my next slide on transport protocol, because that's something to really understand. As you build agents and agentic AI, this is going to define how you're going to build it. And in this DB operator tool, I have used all the protocols, what you see on the screen. Now, there are two primary protocols, STDIO, as the name says, standard input output. If you look at STDIO, it has to run inside a process, right? So I'm running my agent. So your application is my front end application. I have an MCP client connected to my front end. Now, to use my local file system, it's a local file system running on my laptop. So what do? I use a standard IO protocol from MCP. So what that does is it exposes a lot of tools. So for example, my MCP server for local file system, I can read file, write file, copy file, delete file, and do so many things, right? So that's what I have enabled my agent to operate on the local machine. Now, I took the same STDIO. So Oracle recently we brought in a new MCP server called SQL CL, which means the SQL CL MCP server, you can work against an Oracle database. And this SQL CL can work against 19C or any newer version of Oracle databases. So that's what we're going to do. But that's the protocol. So we're going to use the same standard IO. And remember, I said STDIO runs in the process. That means I have to have a local agent running. So in this case, I have a SQL CL, which is nothing but a CLI tool from Oracle, that previously developers used that tool to write SQL query against an Oracle database. We took the same approach. We took that same SQL CL that you have to install in your local machine in the same process, and then we put an MCP server, right, as an adapter. So that's a common gateway now to operate against my database and against any Oracle database in this case through prompt engineering. And then I also have another the Tavily search engine. You can also build a remote STDIO, which means you can have this local MCP server, but you can translate or transfer data to the outside, to the internet. That's what we're going to use. And the last one, I think that's the most important protocol, is going to see the real value going forward, is HTTP streamable. If you think about the name itself, it's a remote server, because I don't want to install all my agents in my local machine. I don't have a use case maybe, right, where I always have to go remotely. So that's where the MCP server, the remote, comes in play. And in this case, we have used the multiple MCP server that I didn't mention one. I have a Redis MCP server. I use the Redis MCP server remotely to do log for model evaluation later on. So I do log everything that happens, interaction within my agents is getting logged there. So in a nutshell, this is how you're going to think about building agents, right? You're going to use tools, you're going to use MCPs, but then you have to decide which protocol to use. And according to that protocol, you build your MCP servers, and you bring those servers to your agents, right? So this is, I touched a little bit where once I have built step 1, 2, 3, now that, remember, I have the goal, I choose my right model, and I have realized that I need all these tools. So I have built all the tools. I have, got all my tools through my MCP server, or also custom tools. You don't need MCP for every tool calling. Then step 4 is where you want to spend time thinking about how my agents will store data and how will they retrieve data, right? So we bring in short-term memory, long-term memory, where short-term means, it resides within the thread of your application, which means once I shut down my agent, my short-term memory will be lost. So that I need long-term memory so that I can start my agent maybe tomorrow. This DB operator does not need a long-term memory to operate, because I'm working on a database. I'm done. My job is done. I'm going to shut it down. But I do use long-term memory. I use a Redis cluster to store it so that I can do analysis on my prompt, so I can evaluate my model later on. So that's where I have used my long-term memory, and you can use it for any other use cases. So this is an important phase of the life cycle, where now we have come to build the memory. We have started thinking about it. Well, this is step 5, orchestration. So now that I have everything ready, so it's time to orchestrate. So there are so many different patterns out there in the industry. This DB operator is very simple. It uses a single or solo agent architecture, but there are multi-agent architecture. There's swarm agents, which means I can talk to one agent, the agent can hand off the prompt to the second agent. So these are called swarm architecture, and there's many more out there. Also, this one thing important to note here is how does the agent process patterns, right? In this case, we introduce human in the loop because it's important that this DB operator, when I'm writing a SQL query, I, as a developer, I, as a DBA, just do not close my eyes and approve my SQL query. It can go and destroy my database, right? So that's not what I want. So I want to approve each and every query before it goes and exit. So I bring a human in the loop element into this DB operator. So again, you'll see in the demo that I can choose between, should I have a human every time? Once you get used to, maybe the agent becomes so good, so autonomous, you can remove that element from that agent. That's also to be considered and thought about. Well, let's now get into the demo part of it. We're gonna show you. It's gonna take around 20 minutes. But before I go to the demo, I just want to finish the slide number 7 because step 6 is where you build the agent, right? That's where you see things happening. The demo of the your agent that comes to life. But before I go to the demo, I want to make sure step 7 is something that we don't forget. We're not going to give a demo of the step 7, but this is the model evaluation phase. This is the agent evaluation phase where I would love to show you how I have done, follow this process here, because every time I build a large language model, I first test it out. I want to make sure that's the right agent, right model for my goal that I've set for the model. So there's a phase, testing you want to do. As you bring all the tools, you want to be able to test independently all of the tools without attaching to the orchestration layer, right? Because we haven't yet written the agent. That's step 5. So at step 3, I mean to say, you want to make sure that you test each and every of your local tools. So there are a lot of tools available. That's not scope of this webinar, but I'm just giving some ideas. And then there are other techniques to really evaluate the whole orchestration. Are you getting the right results? The prompt that you expect, are we getting the right response from this prompt? There's something like human in large language model as a judge. There are a lot of open source eval models out there. And then we build the whole monitoring and the iterate. So that's where I monitor every prompt behind the scene through my Redis cluster that I have. But this is a constant evolution. Make sure by the time you're at step 7, you're getting the right results. And that may be the place where you decide, I need to change some model. I need to change my system prompt because that's not what my model is doing, my agent is doing, right? So step 7 is where is the final step. By the time you are all good with this 7th step, I can tell you that you can deploy this agent into production. All right, Joe, ready to go for our demo part?
Let's see a demo.
All right.
So I'll point out that Anoop recorded the demo in advance. It's not because we're worried that the solution is wobbly or anything. It's just that it leans heavily on LLMs. Every time Anoop suggests a prompt, a request, internally the agent is asking questions of the tools. It's iterating on that. Every call to an LLM typically takes 1 or 2 seconds. So there's some latency involved. So just by recording this and then by playing the demo at I think 2 times speed, we can get to the end much more efficiently.
Sure. And we'll leave a lot of time, maybe 10 minutes for Q&A. I think we are in a good, spot right now, 35 minutes. So this is just the interface. You can build an interface on any technology. I use Streamlit to make it easy. But what you see here is I'm starting the agent. And as I mentioned, I have many MCP servers tools. So SQL CL, MCP server from Oracle is what has been added. Internally, it has 5 tools. So you can execute SQL, you can do so many other things. So those are tools inside the MCP server. So remember, the MCP servers are SQL CL. So Tably is is a third party, not Oracle, by the way. But that's something that I use to do a web scrap, right? The web search. The file server, as I mentioned, it has 14 tools. That means I can do so many things on my local file system. I have the Redis. That's where I can store all my logs into a Redis cluster. That's what is used as an MCP over here. The DB tools, the AI ops, and then there are a few more tools that I didn't print it, which is the Python tool, and there's a few more out there. But this is where I start the agent. Now let's look at this, right? So what I'm gonna do is I'm gonna take two personas. The first persona is the DBA. So we're gonna talk about Vibe DBA. So again, I mentioned before, maybe from 5x to 30x, my performance has gone higher when I have to operate against a database. So in this case, that's the first persona, and the second will be a data analyst. We're gonna switch quickly to that persona, but let's see here what my database agent is doing. Let me move this zoom bar above. There you go. So you can see what I did was I have asked what are the connections I have available. So your DBA that gives you the database will give you this wallet file in Oracle, right? That's how we do. I deploy the wallet file in my local machine because remember I use stdio, which means I need to have a local access to my wallet file because stdio works within your process. So that's the first thing that agents are going to do. I'm going to ask them show me all connections. I have few more in this, but I'm going to use the AI world system because I'm a sys user. I want to be a DBA, right? So I have a local database running for this on my laptop on a Docker container, as I mentioned, not on Oracle Cloud, so I can operate and demonstrate that I can be a developer, a DBA, and then do system level work. So
Hey, Noop, let's explain the three different panels we see here. So below is where you type your prompt. And when the agent delivers the answer, it's going to show up in the middle layer here in blue. But above, I think, is the most interesting part. It's the log of the agent's internal thinking. So the agent is effectively talking to itself as it looks at your prompt and realizes, oh, I should be calling this tool or that tool, and then it'll call that tool and look at the result and decide if that result was good or if it should try again. So all that is transcribed in that log above, which is often very interesting to look at.
and unfortunately for the video, you won't be able to dig into those logs. But yes, Joe, that's the chain of thought. That's exactly what the agent is thinking behind the scene as it takes decision. Let's say in this case, hey, I have this connection available. What went behind, right? Remember, first thing it says, I need to think, I need to observe, I need to see the resources available. That's where it found the resources in my local machine, and then I will take an action. And that action is what it said. Yeah, this is your available connections, and then I'm going to connect. So I'm going to use that first connection and then become a DBA. Like some great DBA told me that first time before or after you connect to a database, the first thing you want to do is to really understand who am I, so that you know who you are and how you're operating. So that's a query. That query actually, I'll just stop here for a second. It's a query, who am I? It's just a basic query. So that's where the human in the loop comes in. So I have a approve and deny. Obviously, it's I know this query, I can approve myself. So I'll go and approve it, but this is what's happening behind the scene. My question, who am I, has been translated to this query. And who translated this query? I think let me deep dive a little bit, right? The large language model. In this case, the one that I've used, the Llama 3 model that you see on the screen, translated that to a PL SQL, but it used the MCP server to go against my database, right? So remember, I gave so many tools. So that was one of the tools it picked by itself. I don't have to really tell which tool to pick. The agent has reasoning capability. It has ability to understand all the tools. It knows which tools it has access to, and it picked the right tool to do the right job. That's what has happened right now. So let this go. It's a simple one. So it will be telling me, hey, I'm a CC user. But the next prompt, is where, let me show you a little bit more, right? Before I go to the next prompt, this is where I bring context. Remember, I talk about file system. So, and I don't want to give access to my entire laptop. I only give access to a particular folder to this agent, right? So where I said, yep, tell me which folder I have access to, and then it tells me this is your, path that you have access to. And then I said, go ahead and remember it. So the next prompt you see here is memorize this prompt, so that in the future, when I say save my file locally, you always memorize this file already and use that file. I don't have to give this part every time, right? So that's called context engineering. So I give a context of a local file. Now let's go and behave as a DBA, right? So this query, if you look at it, I'm asking to list table space, utilization, And free space, it needs a lot of DBA knowledge to really understand your database. But as I mentioned, I'm 30x DBA right now. I'm doing vibing, so I'm able to write a nice English prompt. But I also give my agent more things. I said, just not that I want to build a report. I want, because my manager is asking me the report on my database, so I need to send it to them. So I asked them to build a nice report in HTML format, and then I'm lazy enough to open it. I'm saying, please go ahead and open my in the browser. I can view it. So that's what he's gonna see behind the scene. It's going to take multiple paths, multiple tools, but then it'll bring the final output, which is my HTML file, right? So the logs, unfortunately, I cannot show you on this video, but you see this, the prompt being created, the SQL being created, and then once done, it's executed the SQL behind the scene, and then it also running a Python code. The LLM is writing a Python code to really build a nice visualization because I asked for it. And then what it did was just not that, it also created an HTML file for me and then store it locally and then open it in the browser. There you go, right? So look at this. This is, for me, it was an aha moment, frankly, when I built this, that what Joe was saying, for me to do this, I have learned it, it might have taken a lot of days or many days. Now, within seconds or minutes, I would say, I'm able to build this. And that's the beauty about Agentic AI. That's what I want to talk about when you build this for your enterprise. Follow these practices, and this agentic AI will do a lot for you, right? You can really harness a lot of enterprise data for your organization.
I think that's the main punchline of this demo, Anoop. So in the prompt, you gave it three very short tasks. Go write a SQL query to tell me what my free space is on my database. And if you recall from what we saw in the log, it was a humongous SQL query. So, for database users like us who are not necessarily database admin gurus, we would have spent an hour or two doing Google searches to figure out how to write that SQL query. And then the next part of your prompt was, store all the SQL output, the result of that SQL query into an HTML file so that you can browse it. So that was calling some Python code to grab that SQL database output, push it into an HTML file that you can then browse. So a lot happened in the span of a few seconds that ordinarily would have taken, 1 hour of Google research, an hour of writing Python code to generate that chart. So that's where that 30 times accelerator, I think, comes from. It's agents can do a lot for you in a very short amount of time.
Yes, absolutely. And the next prompt, I bring more context. Remember, what I do here is, assume I do not know too much about Oracle database. So what I said is, what are the best security principles I need to be aware of while building a vector database in Oracle 23.ai. So these are a lot of new things for me. I'm new to this, as an example, as a DBA, or a developer. So I ask relevant knowledge from, I know I have a rack system who can tell me what to do. So what I do is I ask the question. We'll not go too much how we build the rack system. We may be running a little bit, we have 7 more minutes to go for the video. But in a nutshell, a RAG is where retrieval augmented generation, where I took all my documentation, unstructured data, and then it was vectorized inside an Oracle database. We use a embedding model to vectorize. That's what happens behind the scene. And then you store the vectors. And then we do a retrieval. So I ask the prompt, show me best principles. So it also vectorized my prompt. And then it did a semantic search on my vector database. And after that, it gave me these top 3, 4 best practices, right? So that's all happened behind the scene. That's a service, a tool that I have made available to my agent. So that's all done beforehand, right? Before we build this agent. So I have the endpoint, the rack service, remember, where I showed all the tools being added. So that's additional context we apply to my agent. So now I have this, and then I'm going to ask this agent, hey, you know what? Go ahead and create the tables based on these best practices that Anu really is not an expert on, or Joe may not be an expert on, right? So I rely on my enterprise knowledge base versus my own expertise. That's what is happening. I asked them to create a database called day one, demo 3 version. And then also, an interesting prompt, I'm also asking, because that was a vector database. So I'm saying, do one thing. I want to have a README file just for demonstration purpose. It has some text, and vectorize my README file and then insert into my Oracle database vector column, right? So I did a lot of things behind the scene, but with few simple prompts. And then I want to really leverage the power of my agent. So behind the scene, what it does, it's gonna go vectorize. First of all, it's gonna read my README file, and then it's gonna find it from my local, file system that I give access. So that's what is happening. It's reading my text. You see it above in the logs a little bit. And then once done, it's going to vectorize this into vectors, which are like some numbers, right? That's going to be stored. And then it'll create a table. So that's the process going on right now behind the scene.
And again, if you and I, Anoop, had to do this manually, programmatically using code, we would have spent, an hour, if we're doing this in the Oracle database, spent an hour, writing the SQL and PL SQL code to do the vector encoding of your README file, store those vectors in a vector database table, and then make it searchable. And this is all happening, in a matter of seconds instead of hours.
Yep. And if you look at this, I'll just run it a little bit here. That has been created. There you go. So these are all the vectors getting created. And one thing that, interesting happened is it tries to insert this query, and guess what? There's no tables available. So it rethinks, it observes the response, rethinks, and it redoes the whole process. Now it's going to go and create a table because it found that the table doesn't exist before. So behind the scene, chain of thought with the same prompt, it's doing the work for you. Remember, it's agentic AI. You do not expect microsecond request response. Give the time to think and do the right thing. That's what it's doing right now. It could not find the table, but it realized, so it created the table now, and then again, it's going to vectorize and run the process again. And in this case, it's able to finally create these vectors inside a new table that it created by itself, right?
So
And
let
when
me see if I understand this. So the agent was blocked because a pre-existing table didn't exist. So when you say store the vector in a table, the agent realized the table was missing. Did it stop and ask you for permission to create that table, or did it just do it on its own?
because I have the human in the loop, before you run any query, it asks me, actually, you might have not seen that, but I approve that query to create it.
Very good.
Yep. All right, let's switch gear a little bit. We're going to go to a different persona, but hopefully by this time you understood the power of building agentic AI applications and the process that I explained, the 7-step process. Follow the process, you'll have these kind of agents built for you, which is really ready to be deployed in production, right? This is what you see on this demo. And then I saw the Vibe DBA persona. Now I'm going to switch gear, move to a data analyst, right? And Joe, I got this database from you. You gave me the wallet file to connect. I'm not a DBA on this. I only have read-only access to a data set that you gave. Could you explain this data set, before I showed to the audience what it's all about?
So this is an Oracle published data set. It's called the SH data set. SH is the schema. So if anybody here is using Oracle Autonomous Database in the cloud today, this demo data set exists there. So in the SH schema, there's at the center is the sales table. It has about 1 million records. People are buying products. It's easily joined against the products table, which gives you detailed descriptions. There's 50,000 mock customers that are buying these, making these transactions. So it's a very nice mock data set we can use to demo your agent solution. And the way we prepared for this webinar is Anoop showed me his DB agent solution, and I merely invited him to connect his solution to my database, which has all this mock data. So there was, other than handing off Anoop some credentials, it was pretty straightforward to make his agent solution aware of and have visibility into this data set that's sitting in a separate database.
Yes. So let's dive in. So what I did was I disconnected from my previous, that's what disconnect, you'll say, yep, I'm disconnected from my previous database instance with the same conversation. I still have the context from my previous one. So, I can clear the logs. I can also say, forget my previous, I can also say, remove everything from memory. You could have done it. I've not done it in this case, but you can erase your memory so that you bring a fresh new context because you are working against a new database. But There are certain things that I wanted to have previous context, so I did not clear my memory, but I could have done it very well just saying. In this case, I take this JOS database, use data day one demo dash sh, just like in the good DBA friend who told me, I'm going to ask who am I at the beginning, and it will say, I'm just a sys user with have limited knowledge or access to this database. So Joe, tell me a little bit this, and I'm going to write the prompt. Maybe you explain what we
Certainly. So just
are.
to let the audience put eyeballs on the data set, we're asking, give me 5 records from the sales table, which is that's the table at the center of that star schema data set. And it's a million records, but it's a very narrow table. It just has, customer ID on this particular date is buying this particular product and how much they pay for. So that means we can now ask your agent to do some aggregations across this very simple data set. It also do the joins if we need to join the sales table against the customer table or the product table, depending on what we ask. It'll do those joins for us, and then show us the results in line.
Yeah, why don't you explain this? Because you gave me as a business analyst to this agent. I just wrote the prompt on your behalf. Do you want to explain
Certainly.
the prompt? Because it's doing a lot of things behind it right now.
So we want to show off how this agent can use the NL to SQL tool to do aggregations and joins across that data, but in a way that the business analysts can just ask questions of the data of the database without having to write SQL. So in this case, we're asking for monthly revenue, put it in units of millions of dollars. You're also telling it to use the sales table in the SH schema, but then take that output that is generated by the database and effectively call the Python plotting tool. So it'll make a bar chart and then store that bar chart as HTML and then pop it up in your browser. So this one simple, 2 sentence request is gonna invoke several of your agent tools. And this was just you and me spot checking how well your agent works on the data set, and it worked really, really well for this demo.
Yes, I would also add on saying here is, I've been in this industry for the last 20, 25 years. Historically, we have been writing code, we have been building reports, takes months to build reports. You have a BI tool to really, run those reports from, and now a simple agent writing this prompt, I no longer need a BI tool, frankly, to do this work for me, right? Because I'm a data analyst, I can just do it just in front of my eyes, writing simple prompt if I have access to something like what we are showing out here. And this report, yeah, it may not be that good looking, but you can always make it good looking better. You can just say, hey, add some colors to my bar chart, or you can also say what type of chart you want, right? It'll change it for you. And behind the scene, the agent really the large language model. That's why I chose the right one, which was the llama model that can generate Python code to build some of these Plotly, and this uses Plotly as a library to build the graph that you see on the screen. So, and I use my Python Scratchbook to run this on the fly in memory. That means these codes are running in memory, and then there you go. I have a like a BI tools just in front of me, without asking another developer to build it for me, and that would have taken so long, right? So I have data insights right on my fingertips. That's the beauty about this.
Yep. If I had to do this myself, I would have spent maybe 5 minutes writing the SQL query. That's the easy part. Maybe half an hour writing the Python code to recast that SQL output into a very simple bar chart. So again, this is how agents can accelerate your day to day. It helps you scale out very, very, very fast.
Yeah, and we could go on and on. Do again what I always say is go and just explore. This data set is not just the one. We have done so many against large data set. It's something the data is trapped inside your database. You don't know what business inside. Let the agent discover for you, right? You just give them the business ideas, and the agent in this case will go and give you the response that it to the best of its ability. And how we do that? We apply context engineering. Just writing a single prompt may not work. You have to bring the whole context that you saw in the previous slide. Well, things to remember, 3 things. Agentic AI depends on reasoning model. The better it is, the better response you get. MCP, think of it as a USB-C port that you can plug into any agent with the resources that you want to do, right? We saw what we have done with this DB operator. And then finally, this is the whole crux of building from zero to hero. How I build an agent with this simple 7-step. If you follow this process from step 1, don't go to step 7 at the beginning, right? Or to step 5 at the beginning. Follow this process from step 1, 2, 3, 4, 5, 6, 7, and by the time you have an agent ready to go, deploy to production. So here are some quick handy links, GitHub repo, quick actions, what we have, how we deploy on OCI Data Science, Aqua, how we do hosting MCP servers on Oracle Cloud, some service overview, and all the good things that Oracle brings to our customers. You can see some of this link over here.
Thank you. Awesome session. Really appreciate your time with everyone and help with creating the session. I hope it's a great learning experience for everyone. And while we're on the slide, here we have the slide that helps outline various learning resources, labs, and certifications from Oracle University, as well as our YouTube channel. If you enjoyed this session and would like us to conduct personalized training sessions for your organization, please do email us at our personal training email, and we'll reach out to you. And also, if you'd like for us to conduct just a hands-on lab, if you'd like for us to also, or if you like our Live Labs program for a more expedited hands-on learning experience, which can specific, which can deliver specific cloud topics. Also, we have our developer experience program, formerly known as Code Innovate, where we co-develop solutions based on your own use case. Now, please remember that personal training is an investment we make in our customers and help them grow and develop their OCI skills, and we do this all at no extra cost. All right, moving on to the next slide. Here we have a calendar that all our various offerings throughout the month. If you're interested in joining these other sessions, please pay a visit to our Day One Beyond homepage and register. And as you can see, our next session will be Best Practices to Design and Operate Oracle Cloud on November 18th. We hope to see you then. That being said, have a good day, everyone.